Greetings. Welcome to the lecture number 2 of ordinary differential equation. In our previous lesson, we have solved the linear differential equation. In that lesson, we will know how to solve the Bernoulli's equation. That is, actually we will reduce an equation, Bernoulli's equation, in form of linear differential equation, and then we will solve. Let's see how to do it. Look, this is the Bernoulli's equation. L- This terms is actually Bernoulli's equation. Now we will do it a method that we will make it, we know how to solve the linear equation. In here we'll actually do what, that this equation will turn into the linear equation. How? First thing we will do, that we will divide the both side by this term y to the power n, and we will get dy dx plus px by y to the power n into y is equal to fx. Now we got these things. Now let y to the power minus n plus 1 is equal to z. Now differentiate it. If we differentiate it, what we will get? This is minus n plus 1 into y to the power minus n dy dx is equal to dz dx. Now look, this term is that terms, so this is actually, we can write it, so we can write this in that form, 1 by minus n plus 1 can be written as n minus 1, because we do change that form. This is called dz dx dz dx. Now look at another form, that is n and that is y. This expression actually means that y to the power minus n plus 1, that is equal to z p x z, okay, is equal to f x. We got this. Now if we do another thing, that we multiply both side with these terms, or n minus n minus 1 terms, then we will got that dz dx can be written as minus of n minus 1 pxz is equal to minus of n minus 1 of fx. Now look at that equation. This equation we got, this is the linear form of equation what we already have solved in our previous lesson. To solve this equation, actually we'll do what we'll do, we'll find the integrating factor, and then we'll get the solution of that equation. Next, have an example. For more clarity, let's solve a problem. We have a problem is this. This is actually a Bernoulli's form of equation. To solve it, first we have to reduce it to a linear form of equation. To reduce it, we will do what is y by 1 by 3 dy dx plus x by y square is equal to x cube. Now let 1 by y square is equal to z. 1 by y square is equal to z. So that can be, if we differentiate it both side, that will be minus 2 y to the power minus 3 dy dx is equal to dz dx. Now look at this minus 2, if we transfer it that side, then we will have that 1 by y by 3, as it is minus 3 dy dx can be written as minus 1 by 2 dz dx. Now look at this. We can now rewrite this equation in terms of z. First thing, look at these terms. That terms means this. That means minus 1 by 2 dz dx. Now look at that term, x by y square. Okay, 1 by y square is equal to z. So we can write this term x z, and this term is x cube. Now one thing we all more can do is we can do write it in that form, dz is equal to minus 2xz is equal to minus 2x cube. Now look at that equation. This is now a linear form of differential equation, and we know how to solve it linear differential equation. First we have to find the integrating factor. Let's try to solve it. Now we know what is integrating factor is. Integrating factor is, that is e to the power minus p dx. The term p is actually here minus 2z, so we can write that integrating factor can be written as e to the power minus integration of 2x dx. Okay, this is actually e to the power minus of x square. We got integrating factor, right? Now look at that equation. We have to multiply both sides by integrating factor. We'll do it in our next page. After multiplying that integrating factor in the both side, we get this. Now look at this expression. We can write this expression in the form of dx z e to the power minus x square. Okay, look at that expression. We can write it, that is 2x cube e to the power minus x square. Now to solve this, we need to integrate both sides. Integrating both sides, we will get minus x square is equal to integration of minus 2x cube e to the power minus x square dx plus and constant c. Let's find this value of integration to get the solution of that. To get the solution of this integral, let minus x square is equal to t. That means minus 2x dx means dt. Okay, now let's rewrite that integral minus 2x cube e to the power minus x square dx. Okay, now look at that. 2x dx is, we know this term. Now minus x square is equal to, so we can write this. Look at this. So we can write this in that form, minus of t e to the power t dt, dt. We can write this. So now that means t minus 1 into e to the power t. We got that integral. Okay, plus another constant, anything c1, we can write that constant, because what if we do this, we will have obviously the some constant. Now look at these terms. We got this and this term in, if we put this in that term, so we can write, okay, we can write that z e to the power minus x square is equal to t minus 1 e to the power t plus c. Okay, last thing we have to do is just putting all the value of this substitution. That what substitution, like first thing we have to put the value of z. What we have, the value of z is equal to 1 by y square, 1 by y square. We don't have any issue if we take it in the x term. Now the value of t, we have to put the value of t is equal to minus x square minus 1 e to the power t is equal to e to the power t is equal to e to the power t. Okay, yeah, e to the x square. Now t is equal to x minus x square, so that will be minus x square plus c. Okay, now to get the value of this is the solution of ODE. If you can want to it more simplify that 1 by y square in one side, then we can do it, but not necessarily that is our solution. If any you have any query or any question or any doubt, you can ask in all the comment section. Thank you so much.